Welcome everyone to this year's Grace Follow-on Science Team meeting. When we started planning this earlier in this summer, of course, we hadn't imagined that we would all sit in front of a computer distributed around the world. And unfortunately, that is the case this year. But we did want to go ahead and have the meeting because it is important to have this meeting, to have this gathering, come together. It's important for us from the project team to update you, the community, of where the mission is at, what we're doing. And it's even more important for us to hear from you what you have been doing with the data. Um, and that's what we're trying to achieve in the next few days. Give you an update, hear from you, exciting results, new applications, and hopefully have a little bit of an interactive discussion as much as this format allows. Really appreciate everyone being able to pivot to this virtual format so quickly and submitting your slides, submitting your abstracts, and getting back to my requests for confirmation and all that. So really appreciate that. And so I want to welcome you, of course, on behalf of the big, very big international project team, Grace Follow On. There's JPL, there's CSR, there's our partner in Germany, GFZ. There's our colleagues at Goddard who unfortunately are not able to join us today due to the furloughs in the US here. That also means that the presentations in the schedule from Goddard colleagues cannot be given live today, unfortunately. That gives us a little bit of room to have slack in the schedule. So just for format, 4 minutes or a little bit longer for the introduction. I think we're going to sort of call out after 3.5 minutes that you have a minute left. So, 4 minutes, 30 seconds because of those cancellations. And then, we have enough slack in the schedule. We should get through that in about 2.5 hours. Okay, without further ado, then I'm going to jump into the project status update, a few science results, just a perspective, high-level perspective from my side. If you don't know me, I'm Felix Lander. I'm the project scientist here on the US side for Grace Follow-On. Really glad that our German colleagues can join us virtually. Frank Flechner in particular, the German project lead, the PI at GFZ, and the entire team. So, usually I kind of jump in and it gets technical pretty quickly. But as I was looking at the abstracts and the registrations, I realized that there's a lot of new people joining us, grad students. That's fantastic to see. And also, in this year in the U.S. has seen a lot of turnover in terms of people. And I realized there's a bit of a generational turnover in this entire community, and I think it's good to just take a step back for a couple minutes and just remind you how we talk about the missions in general. The missions being the GRACE missions. It's a series of missions now that started with GRACE, partnership between NASA and DLR. Grace Follow-On, which we're flying now, NASA and GFZ, and then we're working already on Grace Continuity. It's launching in just a few years at the end of 2028. So we'll give you an update on that one as well. And that's again a partnership between NASA and DLR, the German Space Agency. So I just want to give you this slide. This is often a very high-level slide that we use for introductions in context where people may not know about, the missions in detail and how we talk about them. And in particular, on this next slide here, as a new administration came in the US earlier this year, there's turnover on that side too, the programmatic side. So we need to always brief and update the new people. In a nutshell, if you just have one slide, what is this mission about? What are these missions about, the GRACE missions? And this is the slide that conveys that. If you just have one slide, we do monthly global mass tracking with GRACE satellites. We call them smart water meters. That's actually a term that wasn't coined by me. That was coined by Niels Hobius. That's where I heard it the first time from a professor at GFZ. Smart water meters for monitoring drought, flood risk, and changes to groundwater, sea level, and glaciers. So, many of you are familiar with these pictures, but in a nutshell, this is what this series of missions is about, and it yields these contributions here to society in terms of its scientific finding and application. So the GRACE missions are vital for advancing scientific knowledge of Earth's evolving water cycle and systems. They provide valuable information for water-related resources and hazards, supporting thriving economies and societies. This last part here in particular will be sort of an emphasis. I'll come back to that at the end of my talk, as this is something that is being sought right now by sponsors and supported programmatically. The focus, at least on the NASA side, but also in Europe, is on applications. Now, what does this data yield for the end user? Okay, I just want to give you that perspective so you know, because I consider everyone in this meeting also an ambassador for the mission. You know how we talk about the mission to the outside world, to our program offices, and you have some language, some verbiage to also be an ambassador and communicate what this mission is about if someone asks you. Okay, this is a plot we always show. We always update every year. Just adding on the new data since we last met in October last year. We added, in this case, actually 13 monthly gravity fields. And in a nutshell, the status is that we've had continuous science data collection and processing. Since the mission start now in 2018, we've delivered these 85 monthly gravity and mass change data sets. They're at a level consistent with GRACE. There's more talks after me that will show that. I'll also have a plot. And all of this is expanding the impactful science results and societal applications. So I'm just going to jump really quickly through these sort of 4 high-level items here. Just one slide on programmatic and mission updates. So this is since last year, since October, since we last met. We're in our third year of the 3-year so-called extended mission phase. We launched in 2018, had 5 years, and so 23, and then we added on 3 years programmatically, 3 years program support. So this is for another year. On the GFZ side, the German side, the mission operations at the German Space Operations Center, they're secured by GFZ through December 29. And that timeline will enable extension of GRACE follow-on all the way through the launch of GRACE C with a 1-year overlap for cross-calibration. On our side, the JPL NASA side, we will have to go through the NASA senior review again, and we expect that the proposal call for that will come out later this year or early 26. The NASA senior review, for that, we're going to have to demonstrate that the mission continues to deliver excellent science and applications value. And this is where you come in. This is where we need to hear from you what you're finding and what you're doing with the data and what impact it's having, right? So this is why we please ask you to communicate with us any kind of end user and stakeholder engagement. In particular, these things are hard to come by. You know, a published paper has a DOI, but these kind of interactions with stakeholders, please communicate that to us so we can show the impact that the data has for water, drought, fire, resources, hazards planning, that kind of thing. So if you're interested in the NASA senior review, if you just want to look that up, what sort of findings from these reviews look like, what is being looked for, how it's evaluated, you can go to this link. You will see senior previous review findings from all NASA missions. I'm going to jump right into the next point, how we have been performing over the last year. There's one high-level metric that we look at, ocean RMS. It's the most fundamental performance metric. That remains stable despite very high solar activity and drag since late 2021. We've been going through solar cycle 25. Since July 23, we have operated the mission in the so-called white pointing mode. We're just letting the satellites point a little bit looser relative to each other. That has reduced fuel leaks that we had observed. So this was a response to these fuel leaks. It has mitigated these fuel leaks and thus increased lifetime. So we don't have an issue anymore making that overlap with GRACE C. It has also improved the level 2 and level 3 data quality through better accelerometer data calibration. And that calibration itself, that we've developed and spent a lot of time on this mission, is very stable and has been very effective in dealing with higher drag environments. We've had no major issues. The mission operations talks, science operations management will detail that a little bit more. And then solar cycle 25 that I mentioned is still high, but has likely entered its declining phase. So that should benefit us, reduce those non-gravitational forces eventually. Of course, our altitude has declined also, but we hope to enter some less choppy waters in the next year or two. So you can see the ocean RMS here is flat. This peak that you see here in October last year, coincidentally, we had our science team meeting in Potsdam. Um, this is high, so high means higher errors because of two things. We had a repeat orbit. Himanshu will talk about that in a second. But we also had a big solar storm, and Himanshu actually took that picture on October 10th. I think it was the last day of the science team meeting in Potsdam, so we could actually see the aurora borealis in Potsdam. Very cool. Okay. I already mentioned the solar cycle. I'm not going to dwell on this one too much. Himanshu will talk about it, but just in context where we're going to launch Grace C here at the end of 2028. So we're here with Grace follow on. And so from here on, it should be a little bit smoother sailing, so to speak. I want to just two more slides before I wrap up. Usually I present some science highlights, science results. Don't have time to do that today, but there's also just too much. But I want to finish, bring it back to this note that I made at the beginning about the value of applications towards stakeholders. So I've been seeing a lot of work towards making the data more useful, bringing it down in both temporal and spatial scale to where our user sits, decision makers, right? They sit at the regional management scale. They manage flood risk regionally. They manage aquifers regionally. And our typical resolution is a little bit larger than that. So data assimilation, data fusion has been really great in bringing our data, our information content down to those scales. And this is just a highlight here. I screenshot it from this really good, nice website that colleagues in Germany are running, Global Water Storage. And Anne Springer here is leading this work in a project at the University of Bonn, assimilating our data into this regional European model. And you can see that the assimilated model captures the GRACE trends much better than the original model that hadn't seen the data. And you can see that also in terms of the extremes, the seasonal extremes, where our observations, the black dots, pull the model, the assimilated model, towards the reality and thus have a more accurate presentation of extremes, both high and low. And that information, you might remember talks presented in the last few years from Matt Rodell. Extremes are increasing on a global scale, wet and dry. Was that sort of bubble animation, if you recall that? So having this information is really valuable to stakeholders. And when we talk about value, we often kind of just throw that out. And I could keep getting asked and to at an increasing pace, how do you demonstrate value? And that's actually really hard. So I was really piqued by this recent paper that came out earlier this year. Value, expressed in terms of money. And what this study did with support from Matt Rodell and Ben Seichik was actually put a dollar value of the assimilated information of GRACE into, in this case, the US Drought Monitor, that tool that Matt and Ben have developed. So this is a retrospective study that quantified the economic value of improved forecast with this product to adjust the soil moisture. And then it was in a retrospective sense, it was shown that that the value of this information is such that flood protection decisions, so it's a flood happened right in 2012 here in the spring season, that the flood protection decisions could have been made 5 days earlier, and the mitigation costs could have been reduced because they could have been allocated more efficiently. So that really provides an end-to-end traceability for how our data actually creates dollar value on the ground. And this kind of evidence here in the paper, but there might be other ways to document this, is really, really important for us as we go into the senior review and document the value of the mission. So if you have interactions with stakeholders, again, my call to you to please let us know, to try to document that in a sense where we can communicate the value of the data. Of course, science is also still important, but this other element is hard to measure, and we need your help. So wrapping up real quick, the achievements in the last year is that we had uninterrupted collection of high-impact gravity mass change and also GPS RO observations. We tend to not talk about these much in this meeting, but this is also ongoing continuously. Producing excellent science results and applications across all Earth system domains. We're well along. I haven't talked about this, but you'll hear about this in a second, about reprocessing both GRACE and GRACE follow-on for release 7. And in terms of outlooks and plans, we'll continue with nominal spacecraft operations. That's our plan, and we'll continue in this white pointing mode. deliver this release 7 reprocessed data set. We're going to start with GRACE later this year and then add on GRACE follow-on in the spring. The fuel budget and orbit decay, those projections, those look very favorable for an overlap with GRACE C towards the end of 2028. And I've mentioned this a couple times now that we're going to prepare for the senior review call on the NASA side, and hopefully by the time we meet next year, we have an update for you that has been approved or is on its way to approving, so we can continue the mission operations beyond next year. So keep sending us your latest and greatest papers and presentations and results. And with that, I'll wrap up here and move it over to the next presentation. Oops. All right. So Shishtoff is going to give us a quick update on the mission operation status from GSOC. Take it away, Shishtoff.
Yes, hello everyone. I'm Krzysztof Snopek, Operations Mission Manager, and I will give a really quick status of the mission. Yeah, that's the status. The mission status is green, and thank you very much. Now I have some more details. Last year we had mostly or entirely routine operations, which include some maneuvers to correct the drift. And from time to time, 3 times last year, we had to maneuver to avoid the collision with other satellites, 2 times on GF1 and once on GF2. And nominal IPU GPS maintenance, we had to restart IPU 3-4 times per month due to announced PLN outages, and also had a small number of IPU restarts, which is similar to the what we saw last year. No significant anomalies. Orbit high is currently at about 450 kilometers. Last year we decayed by 14 kilometers. It was due to the very high stellar activity we had end of the last year. And yeah, that's more or less all. We have no live limiting resources. The gas composition stays on the very low level. And for details, please check the presentation, which is online. Thank you.
Thank you, Shishtoff. You cut your presentation time in half. That's great. Yes, just as a reminder for people, right, we have the website with the agenda up and running. You will find the full presentations often or somewhat longer presentations under those links. You can check there. We can pull those up if there are questions.
Fine.
And while we're going to do questions after this set of presentations. Yeah, Maggie just put the link in the chat again, so you can look there. We'll just keep going with our next presentation. I lost my agenda window here. Oh, here it is. So it's going to be from Himanshu Salve from CSR, just giving a quick update on the science operations management. Himanshu is the science operations manager for the mission. So Himanshu, take it away.
Audio, video, all good?
Yes.
All right, let's see. All right, so let me just start with a summary first. So as we know, base follow-on accelerometer requires additional calibrations. But we've managed to use GRACE GF1 and GF2 data well enough to get very effective ACC transplant, as Felix mentioned. Since July 2023, the mission has been operating in a wide deadband attitude mode with looser constraints, and that has helped sort of arrest the leak rate, which was increasing rapidly in 2022, which the impact of that was that we had degraded data quality on the ACC transplant and hence the gravity fields, and was actually showing to have severe impact on mission lifetime from the fuel perspective. This white pointing has mitigated that risk of the mission life and has improved the science data quality, and I'll go through that in a minute. The altitude projections take the mission life at the moment past 2035. And then the future plans, they include sort of trying to minimize the time spent in the deep repeat orbits. So looking at the thruster leak and lifetime, we were GF1 and GF2 were following these red and blue projections in terms of fuel lost. The green line is another spacecraft which had similar propulsion system, which had leaks, and that was actually accelerating. You could see that GF1 was actually following the green line pretty well. And then when we switched to the white deadband mode, we actually sort of arrested the leak rate instead of allowing to increase. And just taking that projection forward, the unmitigated AOCS was expected to follow this curve. And so that's sort of your possible fuel leak trajectories. Very high uncertainty range, but it does take us past the GRACE C launch. And so leak doesn't seem like the life-limiting factor any longer. It has also helped the solution quality with the new AOCS operations. As you can see here in this inset, that's the F10.7. We had increasing solar activity. 2022, the solar activity was down here, and then recently we've had over 2 times a higher drag. But if you look at the solution quality in the metric that Felix mentioned, we had higher error in 2022 than we have right now, and that's mainly because of that improvement is because of reducing the leak variability using the new operations. If you actually compare it, the drag in F10.7 during GRACE time was down here. Is severely increasing drag here, but the solution quality is comparable between GRACE best years and what we have in the last few months. Just wanted to these peaks were basically the 2 repeat ground tracks that caused the higher errors. As Felix mentioned.
1 minute, Himanshu.
Yes. Yeah.
Sorry, I just said 1 minute.
Oh, yeah, sorry. And so as Felix said, the solar activity is likely past its peak and may be on its downward trajectory, and so we should have less problems with the transplant. One other item is the repeat configuration. We went through the 4-day repeat last October, which ground track looked like this. The upcoming repeat is a 3-day repeat, and it looks like we might have to spend, with the current projections, 7 months or more in this configuration, which is not good for science data quality. And so it's possible we may have to use some fuel to drop through this resonance. The lifetime impact for that might be at most 6 to 7 months going out to 2035. And so just sort of a visual representation of that is if you don't do anything, we'll follow the red trajectory here going out to 2035. If we do drop through the resonance, that would be about half a year or so by the end of the mission life. Back to you.
Thank you, Himanshu. We'll keep going, and please note down your questions. We'll get back to those. So next up, we have Chris McCullough from NASA JPL. Chris leads the operational part of the science data system, and in particular oversees all things level 1. Chris, take it away.
Is the audio video all good?
Yep, loud and clear. Good to go.
Okay. So yes, I'm presenting this on behalf of the whole SDS team from all over JPL, CSR, GFZ, and Goddard. So let me just dive right in. There we go. Okay, so typically I'll show a host of level 1 metrics, but for this I'll just show kind of one as a highlight. So what the metric I have here in terms of level 1 processing performance is this KBR minus GPS range. Essentially, we do the POD using GPS only. We get orbits. We can then take those orbits, compute an intersatellite range, and then we compare that to the KBR. And that gives us a metric of kind of POD performance at level 1. And so you'll see kind of the whole mission lifetime for Grace follow-on here. If you look at kind of the last year or so, everything's nominal. We're below 2 millimeters in this metric, which is very good. And so I'll say this is pretty much representative of all our level 1 performance metrics. They continue to exhibit high quality, even improving slightly since we've moved to IGS 20. But that level 1 processing is in good shape. Let me move along now. So I'm going to switch gears quickly. I'll do that a few times as I go through this. Now onto the accelerometer status, and that is kind of the most, I guess, volatile piece of the mission. So for GF1, we're still nominal performance. We have impulse response issues, but there's no changes within the past year. And GF1 is operating in normal range mode, NRM. For GF2, we still have the performance degradations that we saw shortly after launch with highly correlated noise. That is also operating in NRM with persisting noise features. In terms of data that we release to be used by the community, for GF1, we released this calibrated level 1 ACT product. So ACT for GF1, that involves outlier detection and removal, thruster modeling. For GF2, we release a special product called the ACH, just due to the extra noise and the degraded performance. And that is our hybrid transplant. We put that out for GF2. A few more details on that. The current bundle that we put out operationally for the GF2 accelerometer, which contains the ACH data, is this ACX2 bundle. And that is specifically designed for processing in this wide pointing mode that you already heard about from Felix and Himanshu. And so inside that bundle is this ACH product. That is the product. If you want to pick it up and do level 2 processing, grab it. And then if you want to do other analysis, we provide these two thruster model versions, this AC0 and AC1, which are just different flavors of modeling the thrusts. A higher level summary. So again, we released the ACH in these ACX or ACX2 bundles. Over the operational history, we used kind of ACX for fine pointing, and we're currently using ACX2 for these wide pointing months. It's a little cartoon here that kind of tells you which dates, which one applies to. And this development of the ACH, right, this is where we utilize a transplant from GF1 as well as the GF2 data and some robust modeling that gives us, these high quality results, even though we have some degradation in the performance of the accelerometer. And we keep refining this kind of as we go. So I'll talk reprocessing soon. And when we do that, we'll try and harmonize this ACH release and incorporate updates from lessons learned. Because I think right now we're basically on an operational cadence. So with the reprocessing, we'll have a little bit more time to go back and do some analysis and make adjustments and improvements. So getting into reprocessing now, so Felix mentioned this briefly, we are working on reprocessing both GRACE and GRACE follow-on level 1 data. The level 1 data will be called version 5 or VO5. The corresponding level 2 repro will be called RLO7. And so specifically for GRACE, basically we want to judiciously reprocess GRACE with the same software and configuration that we use for follow-on. This gives us the consistent, stable, long-term multi-mission climate data record through GRACE, GRACE follow-on, and soon to be GRACE-C. I'll go through status, but we've already processed the bulk of 2004 through 2016, and we're planning to complete the GRACE part of the repro by the end of 2025. For GRACE follow-on, a similar process. We're incorporating software updates, and we're working on the initial reprocessing as we speak, and we hope to have this done by spring 2026.
1 minute left, Christopher.
For GRACE reanalysis, right, this is planned to be the final level 1 reprocessing for GRACE. Again, it's version 5. I think some details on what we're doing in there. We've done a lot of updates to POD, transitioning to IGS 20. We've updated our GPS editing. We've increased the processing rate. We updated our antenna maps. I think that is where a bulk of the improvement comes from at level 1, is that, and those antenna map updates. I think the team here at JPL has put a lot of work into that. And then we made some other updates looking at improving the transplant in those later years, 2016, 2017, as well as some corrections to our SCA processing. And then again, the level 2 processing will be released as release 7. And there'll be lots of talks on this as the level 2 talks. Timeline, so we pretty much completed the POD processing. We're nearly complete in terms of processing 2004 through 2016. Just working through kind of some days that require a little extra TLC and manual intervention. And then in progress, we have ACC transplant updates, as well as processing of kind of the non-nominal mission, those first 2 years and the last 2 or 1.5. And then level 2 is in progress. We finalized a lot of the modeling processing strategies. You'll see more details on those in the level 2 talks. And the level 2 is also used as a validation of level 1, right? So we don't call level 1 complete and correct until it's been validated at level 2. For Grace follow-on, it's a similar story. We're homogenizing the entire POD time series with IGS 20. Remember, operationally, we started with IGS 14 and then we switched to IGS 20. So the repro will homogenize everything to IGS 20. We'll roll in a lot of those ACH processing updates that I talked about, some updates to LRI, some new products and improvements. And then again, level 2 will mimic what we have for Grace. And so here's just a cartoon of that same metric I showed earlier, right? What I showed you before was kind of the blue dots. And then you'll see with IGS 20, we've kind of reduced that down to the red dots. So you see the improvement there. And that is all.
Thank you, Chris. Fantastic. We'll move right along, and in the interest of time here. So now we're going to have a block of level 2 talks from the 3 SDS centers. We're going to kick it off with David Weiss from JPL, talk about our efforts here on the level 2 side. David is actually sitting at GSOC this moment, I believe, if you made it out there, for a meeting related to Grace C later this week. But David was able to join us. David, take it away.
Okay, I'll be giving the level 2 talk on behalf of our team. I'll go pretty quick. Okay, so the main message here is that our solution quality has been stable over the last year. I've shown this at the last several science team meetings, kind of color-coded solar flux index on the right-hand side, and then degree variance kind of in yearly chunks on the left-hand side. And the black curve is what's been added since the last time we met. So you see a large kind of increase in power. We expect that due to geophysical trends in the Earth system. And then kind of on the right-hand side, that's where the noise ticks up. And so you do see the three curves at the bottom were when we had very low solar activity. And the higher curves are as the solar activity has picked up. But despite having the highest, I'll say, yearly average solar flux on record so far in the mission, the solution quality has been pretty stable in terms of noise characteristics. And so you see that also on this next plot, which is this ocean RMS. You've seen already a couple of flavors of this. And so what we see is really a very stable record over the Grace follow-on mission. The black curve here on the right-hand side is what's been added in the last year. And we see that repeat orbit that Felix mentioned earlier. That was October 2024. So the main message is that the wide pointing mode that we're in continues to enable improved accelerometer transplant. That's a good situation for us. And then also on the very bottom here, JPL, we released a MASCON solution, which is constrained using geophysical constraints. And so there, our noise levels are a little bit lower than our harmonics. And so those also remain an effective mitigation tool against high solar activity. So the error level there has been very stable. So I'm going to move on to now what we've been doing for release 7 reprocessing. This is a table showing a change in force models, as well as a change in our estimation scheme. And so for the force models, the main thing we've been focusing on the last year is the ocean tides. We're going to move to GOT 5.6 with an ellipsoidal correction, a spatially variable seawater density correction, and also adding third-degree ocean tide constituents from the GOT 5.6 model. And we've separated out our testing here. We're testing force model improvements on Grace follow-on, so I'll show you a plot on that. And then we've been testing our new level 2 parameterization on Grace data. And the main improvement there is using stochastic models of our intersatellite range radar observations, as well as our GPS carrier phase and pseudo-range observations, and then using VCE for the weighting. So in terms of the force model improvements, this is an average degree variance over 12 GRACE follow-on months that are processed with LRI range accelerations. And you see an improvement, a reduction in power, reduction in noise there in the degree variance space. And then spatially, all of the red dots are where we're reducing residuals. These are improvements in post-rate residuals after estimating gravity field. Over the ocean, that's mostly owed to ocean tide modeling improvements to those regions by switching to GOT 5.6. And then those large blocks over land are actually attributed to the static gravity field switch, where we're using GIF 63. And then we've been testing the new level 2 parameterization, namely the stochastic noise models on the GRACE data. Here's an average of 81 GRACE months. And here we see also an improvement, a reduction in noise moving from release 6 to release 7. And so our next step is to actually merge the force models and level 2 parameterization. We don't have results today to show you, but that's what we've been hard at work doing. So here's kind of a summary slide. The main takeaway points: we're releasing our products, stably with a 60-day latency. We have the unconstrained harmonics, and we have our regularized mask-ons. We've had a very nice, stable solution quality over the last year. But we're working on release 7, and we'll hopefully get that out soon.
Thank you, David. Fantastic. Glad you could join us. I know you've had a long flight. We'll go right to the next talk in this level 2 block. It's going to be given from CSR. Himanshu, are you giving that again?
Yes.
Someone else. Yeah, you are, right? Okay.
All right. So let me just start with a summary here, and then go into detail. So I'll focus more on the release 7 reprocessing effort at CSR. So the release, so we have finished processing 2004 to 2016 for the most part. So here's sort of a cartoon of how the DDV scatter has improved from release 1 all the way to release 7 down here. Blue is release 6. The takeaway is that the noise in release 6 at 200 kilometers is comparable to release 7 at 100 kilometers, and over 25% improvement in the noise over the oceans. And then the schedule is what Chris has already talked about. We'll go to the mean field processing for GGMO 7 after spring in about March 2026. So just to sort of visually represent that, on the left side, we have the DDV curve here. The reds are the release 6, the blue is release 7. The black line here is the expected signal in the DDV space from the mask-ons. And you can see that there is a significant improvement in release 7. In fact, the release 7, degree 96, actually shows less noise below degree 50 in the 96, that better than the release 60 solutions here. On the right side is the Ocean RMS representation for the 13 years. You see a significant improvement, and especially for these months when we had deep repeats. This was a 3-day repeat. This was a 2-day repeat, and there's a significant improvement in the errors. And that is represented here in the sort of spatial maps, like a 4-day, 3-day, and 2-day repeat. And you can see the improvement going from release 6 to release 7 in the spatial sense at 300 kilometers smoothing. Here's a representation of the standard deviation over the 13 years for the two cases, release 6 on the left, release 7 on the right. What you can see is that at 200 kilometer spatial scales, there were a lot of signals in release 6 that were hidden behind the noise in the solution. And those are now much clearer. You can see all those signals. The noise is significantly reduced in release 7. And if we take it a step further and push the boundaries to, say, 100 kilometers, a standard deviation, Release 6, basically all the signals were wiped out and hidden behind the error. But release 7, you can still see signals in many places. In fact, the release 7 map at 100 kilometers looks very similar to release 6 map at 200 kilometers. And so that's where this statement comes from, that it's a comparable SNR for between release 6 and release 7 at different spatial scales. And so with that, I will hand it back.
Thank you, Himanshu. Fantastic results. Looks great.
Just
Yeah.
the details of all the processing is in the extended slides online. So if you have any questions, I'm happy to answer.
Yeah. Yeah, good reminder again that the link to the agenda is posted in the chat. You can go there, pull up the more detailed presentations and browse through that, and then also ask questions in the upcoming Q&A. So one more talk in this session this morning, the update on the level 2 processing at GFZ, given by Christoph Dahle.
Yes, good morning, good afternoon. So this is a quick overview on the GFZ level 2 and also level 3 processing. I just have to move the Zoom bar a little bit. So, okay. So we continue to process our release 6.3 graceful on monthly fields since the last GSTM. On the right here, you see the ocean RMS of the complete graceful on time series. And you see that in general, Grace and Grace FO show quite consistent noise levels. And in particular, looking at Grace follow-on, we have this increased solar activity since 22, but this leads to only a slightly higher noise level. So before it was a little bit lower, now we have this level, and all the peaks that you see here are not due to this solar activity. This is always caused by short period repeat orbits. So also this little peak here, that's also a 7-day repeat orbit that we had a few months ago. Right. Now it works. Okay. Now I'm talking about our release 7 reprocessing. So the changes from release 6 to release 7 include, of course, the new version 5 level 1B products, also a reprocessed GPS constellation, updated background models, stochastic modeling of observations, and the AOD background model will be included, and an optimized relative weighting between K-band and LRI. The first two parts are not yet available. So we currently have a preliminary time series, release 7P. And at the moment, we have already 12 years of this setup processed. Here's an overview on these 12 years, also in terms of ocean RMS. So you see that for all months that we have reprocessed so far, we see an improvement compared to release 6. The mean reduction of ocean RMS is about 32%. And I will not show any more details in that short presentation here, because a little later today, my colleague Markus Haug will give a dedicated talk about release 7. But I will tell you now, just here, what's the plan for the next few weeks and months towards the final release 7. So we will finish release 7P for the complete Grace FO period. We will use release 7P to estimate residual ocean tide parameters, which then will update the ocean tide model to be used for release 7. And we will also use the release 7P KVR post-fit residuals to refine our assumption of the observation noise on a monthly basis. And then once we have also the level 1B products and the GPS constellation, we can repeat the reprocessing and obtain the final release 7 time series. And we expect that for Grace to be published end of 25, and Grace follow-on will then follow a little bit later in 26. Then here's one slide about our level 3 products. Level 3 is connected to our Gravis portal. That's our web portal at GFC for dedicated mass change products. There are products for terrestrial water storage, for ocean bottom pressure, ice mass changes. We have also a groundwater product based on the G3P project. Since the last GSTM, we had a few updates.
1 minute left.
For our products, we incorporated GFC release 6.3 level 2 products and also the latest COSG release 2 level 2 products. We are happy also that based on our Gravis and G3P work we've done in the last years, we were selected to contribute now to the operation of the Copernicus Climate Change Service. This means that we provide new climate data records that have been selected, which are TVS, anomaly, and groundwater storage change. And we're also happy that we have finally a Gravis reference paper published. Here's the link. Yeah. And then my final remark is, if you download any data of either level 2 or Gravis level 3 products from our ISDC archive, please note that since June this year, the data has been made available via HTTPS protocol. So you see the links here. And if you still use FTP, just make sure that you change to HTTPS before end of this year. So the FTP access will be deactivated by December 31st this year. And that's all. I think I can skip the summary. I have also uploaded a little bit extended version, which yeah, you can look at the website. Thanks.
Thank you, Christoph. Fantastic. So as I mentioned earlier, there would have been one more talk in this morning session from our Goddard colleagues. Unfortunately, due to the government shutdown here, they're not able to join and give that talk, but I hope Bryant will be able to upload that into the agenda once they're back and we can view the content there. That talk would have been about the TN14 product, so the SLR derived C20 contributions and updates on how Goddard analyzes, produces SLR data and how they're validating that. So unfortunately, can't give that today. So okay, so that wraps up the first session this morning. Thank you, all the presenters. I only have myself to blame for going a little bit over time. I was the worst offender here, but we do have about a good 10 minutes left, a little bit more for questions. So I want to open it up to the community. You can post them in the chat or you can raise your hand. We have about 130 people, so I imagine there has to be at least 1 or 2 questions. I see one from Chao Yang here. I'm just going to read it out. Hi, Christoph. So you mentioned that you will update the ocean tide model for the final repo. Do you mean you will update an existing model using GRACE observations?
Yes, exactly. That's the plan. So we will estimate a kind of residual ocean tide parameters for the major tidal constituents. And our plan is then to add these residual tidal signals to the model that we are currently using. So it will not change the complete model, only probably 8 major ocean tides and only up to a certain spatial resolution, of course. So not to the full spatial resolution that the model itself would provide.
Okay, thank you. We have 3 raised hands, JT, Khosrow, and Srinivas in that order. JT, go ahead.
Hey, we just heard about the reprocessing and the improvement it's having on the solutions. And I was wondering if there was a mapping of the different changes that are made. You know, it's a new GPS processing, new AOD, new tide model. What is the fraction of improvement that is due to each of those new updates in the processing? Which of them are having the most impact and which are having the least impact?
Great question. I'll let, who wants to answer that from level 2?
You want me to take it?
Sure, Chris, yeah, go for it.
So I think David showed in the presentation that we had it broken down kind of all the models together and then all the parameterization, like stochastic modeling together. It's pretty equal between those two, right? So there's a good chunk that comes from, it's mainly the ocean tides that cause the improvement. We did update, ocean pull tides and AOD and all those things, but it's mainly the ocean tides that help in terms of modeling. I'll call that about half. That's gross numbers. And then the other half comes from the stochastic modeling that we do. I don't know if anyone wants to add anything, David or Himanshu or
Yeah,
Christoph.
I'll add one. So yeah, in our case, the same story. The background models do the heavy lifting, and then the stochastic modeling for the observations in our case. And then the third thing we do is also that we are not allowing GPS data to contribute to sectorials greater than 15. And that is having a visible impact as well. And so in the extended slides, I have a breakdown in there and into how each of them is contributing.
Yeah.
Thanks.
GFZ, do you want to add anything to this?
Yeah, so I can more or less confirm what already has been said. So also in our case, the stochastic modeling of the observation brings the main improvement, and also the ocean tide model using a more recent one was giving surprisingly large improvements, I would say. Yeah, and I think a little bit of that stuff will be shown later when Marcus gives us really 7 presentation.
Great. Okay, we'll go on with questions. Cosro, Srinivas, and then Jakob. Cosro, go ahead.
Hello. I have a question for Chris. So my question is about the version 5 of L1B data. So will the LRI delta also be updated? So it's just the KBR, GPS, and ACH data in version 5 of the L1B data.
We'll update the LRI too. So we have some improvements, just processing some bug fixes. So there'll be improvements in the LRI. Obviously, it'll only span when we have LRI, so not into the wide deadband pointing, but there will be LRI updates as well. So that should be an improved data set also.
Thank you. That's great to hear.
Yeah, I just want to add one thing in general. Our processing philosophy in Grace Follow has been a little bit different. We've rolled in a lot of updates that we were able to make as we sort of discovered them. In Grace, we would wait and do a full-on reprocessing. In Grace Follow-on, to really improve the data product as they come in, we rolled those in operationally. So one thing is to really homogenize everything. Chris did mention that, right? But that's a big thing of the reprocessing, just homogenize it. That we get the latest update into even previous years. Okay, Srinivas, go ahead.
Hi, good morning, everyone, and thank you to the presenters for the very nice update. My question is just actually a small variant on what JT already asked. Do we have a sense for specifically the changes in the low degree harmonics from these upgrades, if they were broken down by each of the major changes? And if not, then perhaps we can volunteer to do some work to see that. Do we have a level 2 time series long enough to judge that?
I don't know. Does anyone have a good answer? I don't have a good answer to that. That is really informative.
I would say,
yeah, Mark, maybe. Yes. Go ahead, please.
I would say for CSR, the improvements to the background models are the primary contributor to low degree improvements, low degree harmonic improvements, whereas the covariance inclusion did not improve the low degrees, whereas it does improve the high degrees significantly. And so there is sort of a difference on which part of the spectrum you look at on where the various improvements impact.
Okay, so I'll follow up separately then. Yeah.
Okay, I'll also add that's a little bit TBD. So particularly when you look at, so right, we're still processing everything, but looking at Grace versus Grace Follow-on, the character will be quite a bit different there, mainly because of the transplant. But so that's kind of part of our ongoing analysis as we finish the processing and link the GRACE and GRACE follow-on repos together.
Make a quick follow-on remark, Felix, if you don't mind. I think that would be worth a short technical note, like a 1 or 2 pager summary to distribute once the reprocessing is finished, specifically on the impact on the low degree harmonics.
Yeah, that's a good point. Yeah, definitely noted. Again, a reminder to also post questions in the chat. You can do that there or raise your hand. Next up, we have Jakob.
Can you hear me?
Yes, we can hear you and see
Great.
you
So
well. Yeah.
really good to see you all. Question to David Wiese on a related topic. Actually, you had this nice comparison of color-coded quality measures, degree variances, and other things with F10.7, so with solar flux. This looked very clear, and I don't remember that I have seen something on this published. So I wonder, did you or will you publish something on this? Because this looked really interesting.
Yeah, nothing's published on that. I think we just use it as kind of a first order approximation on solution quality, but I think that's a good note. I think that's noted. I don't know, Chris, if you want to comment on any of the ACH papers that have been.
David, do you want to just throw up that slide actually, if you have it handy?
Sure.
Yeah, and while you do that, I'll just add. So I think a lot of that is linked to the kind of the transplant ACH processing. So we have on the to-do list, right, to publish. Basically, I don't think we've published, other than at the GSTM, anything on this wide deadband process. So we have it on the list to, write a paper and kind of go over, 1, that process, and 2, the science impacts. And so this falls under the science impact. So I think this would all go together in either a big paper or some combination of papers. So it's on our to-do list. It's in the plan.
Yeah, we are working on, comprehensively describing and summarizing the performance throughout mission lifetime, excluding the prime mission, extended mission, properly documenting all the things we've done. I did just mention, right, that we have rolled in operationally a lot of updates that aren't necessarily always well published. We've been doing that in order to really give sort of the improvements, pass them through to the end user as fast as possible. That has come at the expense sometimes of properly publishing, documenting that. One remark though on the plot on the left. So this separation here, keep in mind that little inset comment is important, that this the geophysical power is still in there, the trend hasn't been corrected, right? That separation in the colors isn't all solar flux, of course. There's a lot of trend in there. I think, David, in the previous slide, you had the ocean RMS and similar color coded.
Right.
Right, yeah. So not everything is F10.7. That more Scion things centered around 2023. That's when the leak was strongest because of the transplant, right? That is our dominant error source, and the leak is hard to model and remove. That's where our reprocessing effort on the level 1 side will focus. Chris has developed a really nice breakdown into the components of all the ACX bundle comes with a lot of models and components of non-gravitational acceleration. So we have some ideas on how to improve that. And we're going to focus our attention there. But that's mostly, or a lot of it is that leak and the difficulty of modeling and accounting for that properly in a transplant.
Yeah, and that's why the wide deadband helps so much. And I will add, the solar flux F10.7 is a good metric, but it is not the whole metric. There's a lot of things. What drives is a lot of the more transient variability in the atmosphere, like solar storms. That's a bigger driver than I would say maybe this F10.7 in most cases. But it's hard to show as a nice metric. So the F10.7 is kind of the proxy metric that we use.